Hey everyone, hope everybody's doing well, enjoying their at-home time. Everybody's being safe and all that good stuff. Today I decided to add my lovely face into the PowerPoint so that way you guys can see me, because I know you missed me. It is true, the camera definitely adds about 10 pounds all in my face. So anyway, let's go ahead and talk about today's lesson, which is concentrations of solutions. All right, guys, let's go ahead and get started here. I put up a copy of my blank notes up on my website. Hopefully you printed it out so you can kind of be following along with me as I go, just like we would be doing if I was in class. If not, just kind of pay attention. You might want to have a sheet of paper out anyways, especially when we go through the problems here in a little bit. Or if you have any questions that you want to ask while I'm working, just jot them down and then obviously email them to me and I'll get back to you as soon as possible. So what we're going to start off today first is by talking about a couple definitions. The first one that we come to is the word concentration. Now again, concentration deals with how much solute is in an amount of solvent. And there are two different types we can have. We can either have a dilute solution. A dilute solution doesn't have a lot of solute dissolved in the solvent. It's pretty weak. Whereas you have a concentrated solution. A concentrated solution obviously has a lot of solute dissolved in the solvent. So you can kind of see in the little diagram over here on the right side of your screen, we have two different types. We have our dilute and our concentrated solution. And think about this. A lot of you guys that make Kool-Aid or something like that at home, some of you guys like your Kool-Aid a little bit more dilute, don't like a whole lot of the sugar dumped in there, whereas some of you guys like a whole bunch of sugar dumped in there. So that way, it's just kind of personal preference. You can think of it that way. Concentration can either be expressed as qualitatively or quantitatively. Remember, qualitatively depends on a quality of the thing. Something like concentration, maybe you would be, if we're doing Kool-Aid, based on the taste of it. Quantitative, we can measure in a certain amount, like how many cups of sugar you guys put in or something like that. All right, so looking at the concentration, there's a couple different things that we have to measure. One of it, the first thing is the percent by mass, which you guys can see here is the ratio of solutes mass to the solutions. The equation that goes along with it is popping up now. It says the percent by mass is the mass of a solute over the mass of solution multiplied by 100. Now, one of the things that everybody seems to always mess up is this bottom part down here, and you got to pay attention. It says mass of solution. So if you go back and remember for a long time ago, the solution of something, so solution, and as I write this out for you, equals solute plus the solvent. Okay? So again, that's very important. Everybody seems to always mess this up whenever you use this equation, but the solution is solute plus solvent. Okay, so taking a look down here at this problem, it says what is the percent by mass of NaHCO3 in a solution containing 20 grams of NaHCO3 dissolved in 600 milliliters of water. So your NaHCO3, that's your solute. The solvent is the water. Okay, so the first thing we're going to do is set this equation up. So you can see that I have 20 grams. So I got that from the problem. That's my solute. And I'm going to divide it by 620. Now, you're going to say, where did 620 come from? It says 600 milliliters of water. A couple things here. The first thing I want you guys to understand is that we're in milliliters of water. So it says hint, 1 milliliter equals 1 gram. So it's 600 grams of water. But remember, it's mass of solution. The solution is water plus the NaHCO3. So I got 600 plus 20 to give me 620. Okay. Go ahead and solve it out. So 20 divided by 620, multiply it by 100, and I got 3.2258%. Now, if I'm going through and doing significant figures, you can see that in the problem, 20.0 has 3 significant figures and 600.0 has 4. So my final answer should have 3 significant figures. Okay, so sometimes your concentration can't be measured by a percent by mass, but you need a percent by volume, which is going to work in the same kind of thing. It describes solutions in which both a solute and the solvent are liquids. Last time we saw it, we had a mass and a liquid. This time we both have 2 liquids. So the percent volume equation is going to look very familiar. You have volume of solute divided by volume of solution multiplied by 100. Again, please make sure you see that here we have volume of solution. Again, solution is the solvent and the solute put together. So it says, what is the percent by volume of ethanol in a solution that contains 35 milliliters of ethanol dissolved in 155 milliliters of water? Okay, so again, taking a look here at our equation, I have 35 milliliters of ethanol, that's my solute. The solvent is the water, so 155 plus 35 gave me 190. Again, it's solution. Okay, go ahead and solve that out, and when I did, I got an 18.4%. Looking back at significant figures, I should see that I'll need 18%. All right, so the next term that we're going to be talking about is molarity. Molarity deals with concentration. You can see that it's the number of moles of solute in 1 liter of solution. Molarity you've probably seen before, you've just denoted by a capital M. Whenever we work in lab, we've dealt with stuff that's 1 molar of this, 2 molars, 3 molars. We haven't dealt with anything super concentrated yet. If we had something that was 6 molar or higher, it would be pretty concentrated. Obviously, the higher the concentration, the more damaging it could potentially be. So you can see that the equation that goes along with this is molarity is capital M. It's moles of solute over liters of solution. So again, you can see we're dividing by liters of solution. So let's take a look at a problem here. It says, what is the molar concentration of 1 liter of solution in 0.5 moles of solute? So let's go ahead and plug our numbers into our equation. We see that capital M for molarity equals 0.5, which are moles of solute, divided by 1 liter of solution. Pretty simple problem. All you got to do is divide out. When you do, you see that you are with 0.5 molar solution. Now, another unit that goes along with this, remember it's moles over liters, so you could have put moles over liters or just simply capital M. Either way works. All right, let's look at a little bit more challenging problem. So number 2 here, it says you have 3.5 liters of solution that contains 90 grams of sodium chloride. What is the molarity of the solution? All right, so in this problem here, we look at our equation above, it says we need moles of solute. Well, our solute is sodium chloride, but it gives us 90 grams. So the first thing that we're going to have to do is take that 90 grams and divide it by its molar mass. So remember, starting in the top left of our little bridge, we have 90 grams of sodium chloride, and we're going to divide that by 58.44 grams of sodium chloride. Again, I just got that from the periodic table. We know that equals 1 mole. Go ahead and solve it out. When you do, you should have gotten about 1.5 moles of NaCl. Now, we have our number of moles. So again, this equals the number of moles, and we now have the top part of our equation. Okay, we have the top part of our equation. So we have our moles of solute, which was 1.54. It told us in the problem that we had 3.5 liters of solution. So we're going to go ahead and divide 1.54 divided by 3.50. And you should have gotten roughly about 0.440 moles, or molar solution. All right, so to continue to talk about molarity, sometimes you might need to make a more dilute solution from something that's a little bit more concentrated. I do this all the time. When I'm prepping your guys' stuff, I have to have, like it's 6 molar or something, I got to make it down to 3 molar, so I have to be able to dilute it. To dilute the molar solution, you need the following equation, which is M1V1 equals M2V2. M's stand for concentrations, V stands for volume. Okay, so let's take a look at the problem down below. It says if you dilute 1 liter of 0.5 molar solution to 2 liters, what is the next concentration? So again, we start off with our equation, and I'm going to go ahead and put things into my equation. So we have 1 liter of solution times 0.5 molar equals, we don't know the second concentration, times 2 liters. So I'm solving for M2, so I'm going to rearrange this. So I'll have 1 times 0.5 divided by 2. When I solve that out on my calculator, I should have come out with 0.25 molar. Okay, so the next term that we're going to talk about is molality. Molality is a little bit different than molarity. They still are going to measure a type of concentration, it's just a different form. Remember that molarity dealt with moles per liter of solution, in molality, you can see that we have the moles of solute per kilograms of solvent. So it's a little bit different, just a different way to figure out the concentration, okay? So looking at the equation, we see we have lowercase m for molality equals moles of solute over kilograms of solvent. Okay, so again, the key difference here you see is the bottom part, we have kilograms, and it's also just of the solvent. It's not of the solution, okay? So looking at problem 1, it says, what is the molality of a solution containing 10 grams of Na2SO4 dissolved in 1,000 grams of water? Well, it gives me a mass of solute, which I don't want. I need moles. So the first thing I'm going to do is 10 grams of the solute, which is Na2SO4. I'm going to divide that by its molar mass, which is 142.05. And when I solve that out, I got 0.0704 moles of Na2SO4. Okay. After I did that, I now have moles. I got to divide by kilograms of my solvent. My solvent's water, so I got to convert that to kilograms. Okay. So following my little equation here, you can see that moles of solute goes up top, and I got to change to kilograms of water. So that's where the 1 comes from. Okay, 1,000 divided by 1,000 gives you 1. All right, solve it out, and you see that you get 0.0704 mole, or moles per kilogram, of concentration. Okay. All right, taking a look at number 2 here. It says a solution was prepared by dissolving 81.3 grams of ethylene glycol in 166 grams of water. It says find the molar concentration of the solution. I'm going to let you guys kind of go ahead and try this one on your own to see if you guys can do it. So I'm going to pause my PowerPoint here for a second, and I'll pick up in a minute or two. All right, I'm giving you guys some time to take a look at that problem. So hopefully you were able to figure it out and solve with what we're looking for, okay? So in problem 2, again, we have 81.3 grams of ethylene glycol and 166 grams of water. So the first thing you're going to do is take that ethylene glycol and divide it by its molar mass to give you the number of moles. Okay, so the first step, again, I took the 81.3 grams of ethylene glycol, I divided by its molar mass. The molar mass was 62.08, and when I did, I got 1.31 moles. Now remember, that's the top part of my equation. So I'm going to take that number, and I'm going to stick it into the top part of my equation. Now the bottom part, again, I had 166 grams of water. If you remember from the equation above, it says kilograms of solvent. So I got to convert my 166 grams of water to kilograms. So that's where the 0.166 grams comes from. I go ahead and solve that out. When I do, it comes out to being 7.89 mole, or moles per kilogram. All right. So at the bottom here, it says concentrations are expressed as molalities when studying properties of solutions related to vapor pressure and freezing point changes. This is because it does not change with changes in temperature. Okay. So that's why molality is used. Again, it's not going to change when there's a change in the temperature. Okay, the last thing we're going to talk about is the mole fraction. It says the mole fraction is the ratio of the number of moles of solute or solvent in a solution to the total number of moles of solute and solvent. It's noted as this equation here. XA equals Na over Na plus Nb. XA is going to equal the mole fraction of whatever substance you're looking for. Na is going to be the moles of that mole fraction you're looking for of the substance. The Nb is going to be the number of moles of the other component in the equation. Okay, so again, whatever you're looking for, we're going to call that Na, and the other one we're going to call Nb. All right, so it says the solution consists of 2.5 moles of ethanol and 3.5 moles of water. Calculate the mole fractions of ethanol. So in this case, again, we're looking for ethanol, so we're going to call that XA, and then, of course, the number of moles for it, Na. So the 2.5 moles of ethanol is going to be Na, and the 3.5 moles of water is going to be Nb. Okay? So we have 2.5 moles of ethanol divided by 2.5 moles of ethanol plus the 3.5 moles of water. Go ahead and solve that out in your calculator. And when you do, you should have gotten roughly about 0.41667 or 0.416 repeating. Again, we need to have significant figures, which we see we have 3 here. So we're going to go ahead and round that up to 0.417. There's no unit for this, so you can just give me the fraction that you get right there. That's all the notes I have for you today. Hopefully this was helpful for you. If you have any questions, again, please reach out. Just email me or anything like that, and I'll help you out as best I can. If we don't understand something, you don't understand something in the notes or the practice or anything like that, again, I'll help you out as best I can. We can always set up a meeting in the Microsoft Teams thing or anything. That way we can make sure that we all get the right information and all that kind of good stuff. Anyways, hope you guys enjoyed the notes. Hopefully I didn't put you to sleep with my lovely voice and my face in this PowerPoint. But yeah, I guess I'll see you next week.